Assalamu alaikum. Hello everyone. My today's lecture is about resistance and the capacitance. What is resistance and what is capacitance? How can we calculate the value of resistance and capacitance when these two components are in combinational circuits? Combinational circuits means when these components are in series, or if these components are in parallel. So how can we calculate the equivalent values, their total value? This lecture is all about these questions. This lecture have some basic objectives that are to understand the active and passive components, to calculate equivalent resistance in series or parallel circuits, to calculate equivalent capacitance in series and parallel circuits. So this lecture, it covers this first objective, that what is basically active and passive components. For these second objectives, you have to watch my second video that will cover these two topics. How can we calculate when these components are in series and in parallel? So here we start our first objective, that was active components and passive components. So those devices or those components which require an external source to perform their operation are called active components. We have different components. Some components require some kind of external signal or external source, then they perform their operation. For this scenario, we have a best example of a mobile phone. Like we have a mobile phone and we have a battery. When we put that battery in that mobile phone, it simply powers on. And when a mobile phone it turns on, it is not more than a electronic device that just took some kind of voltages and shows us the display. For the proper operation, for the proper working of that phone, what we do, we insert a SIM card, a network card in that phone. That SIM card or that network card provides a network. It allows phone to make calls. It allows phone to send messages. It allows phone to use internet. Wi-Fi or Bluetooth, these are some other things that are basically the specifications of that phone. So I'm just talking about a very basic phone. A phone that performs its operation when we put an SIM card in that phone. That SIM card is basically the external source. Similarly, in electronics or in electrical term, those components that require an external source, this external source can be an input current signal or an input voltage signal. Those components that require this external source, that are called active components. For example, we have diode, transistors, or SCR. SCR is basically silicon carbide resistor. It is a modern type of transistor based amplifiers. So diode, transistor and SCR are the active components. Just like that I have explained here. When we connect a diode in a circuit and apply voltage, that diode will not conduct current until the supply voltage reaches to the 0.3 in case of germanium and 0.7 in case of silicon. So diode is a device that performs its operation when we turn on the voltage, source voltage. In the case of germanium diode requires 0.3 volts, and in the case of silicon diode it requires 0.7 volts. So diode is that device or that component when the input voltage reaches to the specific 0.3 or 0.7 value, then this diode will perform its operation. It will conduct current. Similarly, this transistor is used in amplifiers. So you have not seen any amplifier that works without an input signal. Like every transistor or every amplifier that amplifies some kind of signal, it basically takes some input signal. So transistor and the amplifiers are also active components because they require an external source to perform their operation. Without that external source, they cannot perform their operation. Like a mobile phone, without a network SIM card, a mobile phone is just an electronic device that turns on and shows you display. You can play games, you can use calculator on that phone, but basic functionality of that phone cannot be performed until or unless you put an external source, an external SIM card in that phone. So these are the active components. So what is basically passive components? Passive components which do not require external source to perform the operation are called passive components. So a mobile phone without SIM card is basically a passive component. It just took voltages. It just took voltages from the battery and shows you display. It simply works like a normal device. Then it will be a passive component. And when we put a SIM card in that phone, it will work. It will perform all of the functionalities for which that phone is created. Then it will behave as an active component. So those components that do not require external source are called passive components, like here resistor, capacitor, and inductor. So the resistor that does not require specific 0.3 or 0.7 volts, when we connect resistor to the supply voltage, it starts work automatically without any specific voltage. Similarly, a capacitor, when we turn on the voltages, it starts to store those voltages regardless of any specific value. So in the case of active components, I was talking about a specific value that a diodes take, like a silicon diode was taking 0.7 volts and germanium diode was taking 0.3 volts. In resistor or capacitor case, it's not like that. This resistor that does not depend upon any specific value of voltage, and the capacitor does not depend upon any specific value of voltage or current. Similarly, inductor does not depend upon any specific value, that this value will be provided, then I will do my work. No, it's not. Only the active components are like that, if the specific value is provided to us, then we will do our work. The passive components are basically the simple components that work when we give them input and they perform their work and they give us our output. Like here in this picture, we have a diode, transistor, and an SCR. These three are the active components, and the resistor, inductor, and the capacitor. These three are the passive components. So I'm going to tell you a major difference in active and passive components, that is basically a difference of their legs. Like here in the case of resistor, it has two legs. In the case of inductor, it also has two legs. In the case of capacitor, it also has two legs. So most of the passive components have only two legs. Like here, as you can see in active components, this transistor and this SCR has three legs. This diode, somehow this has two legs, but this transistor and this SCR and other active components, mostly they have three legs. So that is a major difference in active and passive components. Why there is an external, there is third leg, I am going to tell you this, that in the case of resistor, you just simply connect a resistor in a circuit. One leg of the resistor is connected to the one side of the circuit and other leg is connected to the second side of the circuit. Similarly, in the case of inductor, this inductor is just attached with series in a wire or in parallel. One leg is connected to the one side and second leg is connected to the second side of the circuit. So in the case of active components, two legs are basically used for the same purpose. This first leg and this second leg, these two legs are connected in the circuit, and this third leg is basically used for that external signal, that external source. Basically, if we are using a transistor amplifier, this third leg will use some kind of audio signal. If we are using SCR for producing some kind of power amplifier, this third leg will use an external signal that will tell us that how we have to amplify our power. We have to amplify just voltages, or we have to amplify the current, or we have to amplify our total power. That decides this third leg. In the case of SCR, this third leg is used for external signal. In the case of transistor, this third leg is used for external signal. So every more or unless every active element or active component will have three legs or more than three legs. Some active components have four legs, some have two legs. There also exist active components that have two legs, like this diode, but the functionality of diode also work as a transistor, but this diode depends here on a specific voltage, but this resistor doesn't depend on any specific voltage. So just in their physical terms, there is a difference that this transistor or this SCR or active components can have more than two legs, or passive components will only have two legs. Okay, so in very simple words, there is a summary that active components, those devices or components which produce energy in the form of voltage or current, are called active components. This is another definition in the form of voltage or current. You can also use it when you are going to explain the active or passive components. Active components are those components that produce energy in the form of voltage or current, are active components. Like a transistor or an amplifier that produces amplified voltage or amplified current, the amplified value from the input value. Basically, this is performed by an amplifier or by a transistor. So those components that produce energy in the form of voltage and current are called active components, and those components which store or maintain energy in the form of voltage or current are known as the passive components. Here it is more easily explained to you that those components that store or maintain the energy. Capacitor, that stores energy. This inductor, it also stores or maintains the electrical field or a magnetic field. Similarly, that resistor, it just works on electricity. When we provide it electricity, and it provides resistance, and it simply do its work. So those components that produce energy in the form of voltage current are active components, and those components that only store or maintain energy, there are the passive components. So active components are basically the energy donors, and the passive components are basically the energy acceptors. So here I hope you have completely understood what is the active component and what is the passive components. So as this lecture was about the capacitors and the resistors, so capacitor and resistor both are the passive components. So here I am ending my first video that was just about the active and passive components, and the second video of this lecture, in that video I'm going to explain that how can we calculate the value of capacitance, equivalent capacitance and equivalent resistance when these components are connected in series circuits or in parallel circuits. So for that, please watch my second video, and if you have any question, then please ask here in comments. Okay, that's it.